Hello friends, so here we are with another question on KVL and KCL application. Again, this is a circuit here which have been given, and the current directions through the branches have been assigned in the question, and there are three cases where we have different values of this unknown resistance R. Okay, this R, which is not actually unknown, but different values are given, and we have to find the branch currents that are assigned I1 and I2 for each of these cases. And there is a third case where we have to find the value of R when I1 is equal to 0. So we have redrawn the circuit here. So let us assign the currents which is given as per the question. So this is I1 plus I2. Here I1 is flowing through 0.2 ohm and I2 is flowing through R. So polarities have to be assigned plus minus, plus minus, plus minus. Now we have to apply KVL. So there will be two KVL equations. First, for this loop, the left hand loop, let us call it KVL equation 1. Another for this loop, this second loop, so this will also be another KVL equation 2. So let us write the KVL equations. So KVL equation 1. So here it will be 130 minus 0.2 into I1 plus I2 minus 0.2 I1 minus 110 is equal to 0. So here if we write it in a different way, it will be 0.2 into I1 plus I2 plus 0.2 I1 is equal to 20. What we have done, 130 minus 110 is 20. That we have kept in one side, and this minus 0.2 into I1 plus I2 and minus 0.2 I1 we have taken to the other side, so it became positive. So again simplifying it further, it will be 0.2 I1 plus 0.2 I2 plus 0.2 I1 is equal to 20. That implies 0.4 I1 plus 0.2 I2 is equal to 20. This is the equation, this is the first equation. Then KVL equation for loop 2, the right hand side loop, KVL equation 2. So it is, let's say, 110 plus 0.2 I1 minus I2R is equal to 0. So it is, let's write in a different way. If we write it, it will become minus 0.2 I1 plus RI2 equals to 110. This is the KVL equation 2. So we have to substitute the values. Case A, when R is equal to 2.3 ohm. Case A, when R is equal to 2.3 ohm. So what we have to do, first we write equation 1, 0.4 I1 plus 0.2 I2 equals to 20. This is equation 1, we know. Then we write equation 2 substituting the value of R. That is minus 0.2 I1 plus 2.3 I2 equals to 110. So now we have to use variable cancellation method. So what we have to do is simply we multiply this equation with 2. When we multiply this equation with 2 and we add these two, this gets cancelled. Then we have 4.6 I2 plus 0.2 I2, which is 4.8 I2. 4.8 I2 is equal to 2 into 110, which is 220, plus 20, which is 240. That implies I2 is equal to 240 by 4.8, which is equal to 50 ampere. This is equal to 50 ampere. When we substitute this value I2 in equation 1, let's say, then I1 will be 20 minus 0.2 into 50 by 0.4, which is equal to 20 minus 10 by 0.4, which will be 25 ampere. This will be 25 ampere. So this is I2, which is equal to 50 ampere, and this is I1, which is equal to 25 ampere for case A. This is for case A. Then we have to do for case B, which is R is equal to 0.5 ohm. Case B, R is equal to 0.5 ohm. So here again we have to write the equations. 0.4 I1 plus 0.2 I1 is equal to 20. That is equation 1 as it is, we have to write. Then we have to write equation 2 substituting the value of R. That is minus 0.2 I1 plus 0.5 I2 equals to 110. Okay, then the same procedure we have to use variable cancellation. So we'll multiply this with 2, add it together, this will get cancelled, this will become 1.2 I2. This is I2. Okay, this is I2. This will become 2 into 0.5, which will be I2. I2 plus 0.2 I2 will be 1.2 I2, which is equal to 220 plus 20, which will equal to 240. All we are doing this to cancel out I1 because it is easy. Yeah. So I2 is equal to 240 by 1.2, which is equal to 200 ampere. I2 is equal to 200 ampere. When we substitute I2, this value, in equation 1, we will get I1 is equal to, I1 will be equal to 20 minus 0.2 I2, 20 minus 0.2 into 200 by 0.4, which will be equal to 20 minus 40, 20 minus 40 by 0.4 minus 20 by 0.4, which will be equal to minus 50 ampere. So I1 will be minus 50 ampere. So what this means is that the current direction in case B will be opposite. Okay, here I1 will not be flowing into 110 volt, that is downward, but it will be actually upward. The magnitude is correct, but just the sign is opposite, so the assumed direction which is given in the question will be opposite for case B only. Okay, so here we have found I1 and I2 for case B. Okay, this. Now case C. Case C is when I1 is equal to 0, we have to find R. So let us say we substitute this equation 1 with I1 is equal to 0, that is 0.4 I1 plus 0.2 I2 is equal to 20. We substitute I1 is equal to 0, so it will only be 20 is equal to 0.2 I2. So it will be 20 is equal to 0.2 I2. That implies I2 will be 20 by 0.2. 2. Okay, so that will be equal to 100 ampere. I2 will be equal to 100 ampere. Then when we substitute this I2 value in equation 2, that is 100 I2 is equal to 110, Ri2 is equal to 110, okay, Ri2 is equal to 110, that is the equation. Why? Because I1 is 0, so this term will become 0, minus 0.2 I1 will become 0, that is the condition. I1 is equal to 0, this is case C, isn't it? I1 is equal to 0, so Ri2 is 110, I2 is 100, that implies 100 R is equal to 110, that implies R is equal to 110 by 100, which is equal to 1.1 ohm. R is equal to 1.1 ohm. This. So we have got. It was asked to find the value of R when I1 is equal to 0. So we substituted I1 is equal to 0 in equation 1. We got the value of I2. Then we substituted that value of I2, which is 100 ampere, in equation 2. Okay, and we got 100 R is equal to 110. So R is equal to 110 by 100, which is equal to 1.1 ohm. So R is equal to 1.1 ohm. So for all the cases we found out what was asked. Okay, the values of I1 and I2 for case A and B, and the value of R for case C. Okay. Hello friends. So here we are with another question on KVL and KCL application. So this is the circuit diagram that we have, and it has been asked to find the current that is supplied by each voltage source, each battery. There are two voltage sources, 8 volt and 12 volt, and we have to find out the current supplied by each. Okay, so first step is the assignment of current directions. So here let's say this current from 8 volt, let it be I1, let this current be I2, and let this current flowing from 12 volt is I3. Okay, now here I1, I2 is flowing away, so this one will be applying KCL, basic application of KCL. Current flowing through the AE branch is I1 minus I2. So here for for easier analysis of the circuit, we have named the nodes, okay, A, B, C, D, E. Okay, this is here I2, and here I1 minus I2 and I3. I1 minus I2 is flowing towards node E, I3 is flowing towards node E. So this current will be I1 minus I2 plus I3. This. Okay. Now we have to assign the polarities. Current flowing from positive to negative, positive to negative, positive to negative, here also positive to negative, here positive to negative. Okay, so we have assigned the current directions and the polarities. Now we have to apply KVL. So let us just bring it to one side so that we have more space for KVL. Okay, here. So now we have to apply KVL. So first let us apply KVL in the loop A, B, C, this left loop. Okay, A, B, C, A, B, C, A, this left hand side loop. So that will be 8 minus I1 minus 40 I2 is equal to 0. This is the KVL equation. Then let us apply KVL in this middle loop ACEA. KVL in the middle loop ACEA. So that will be minus 40 I2 plus 10 into I1 minus I2 plus I3 plus 10 because we are moving from minus to plus. Then plus 20 into I1 minus I2. Again we are moving from minus to plus, that's why plus. So let us simplify this. Minus 40 I2 plus 10 I1 minus 10 I2 plus 10 I3 plus 20 I1 minus 20 I2 equals to 0. So let us bring all the coefficients in one side. 10 I1 plus 20 I1, so that will be 30 I1 minus 40 I2 minus 10 I2 minus 50 I2 minus 70 I2 minus 70 I2. Then I3 is only 1, so plus 10 I3 equals to 0. Okay, this is the equation 2. So let us just put them in boxes, this one and this one. Okay, so now let us apply KVL in this right hand side loop, that is CDEC. KVL in loop, the right hand side loop CDEC. So here the KVL equation will be 12 minus 2I3, 12 minus 2I3 minus 10 into I1 minus I2 plus I3 minus 10 into I1 minus I2 plus I3 is equal to 0. Okay, so if we bring all the other things on one side, that is 2I3 plus 10 into I1 minus I2 plus I3 equals to 0. Equals to 0. No, it will not be 0, it is equal to 12. It is equal to 12 because we have brought 12 to the other side. It will be 12. That implies if we simplify it further, bringing all the things on one side, it will be 10 I1 minus 10 I2 plus 12 I3 is equal to 0. 12 I3 is equal to 12, sorry, is equal to 12. Yes, this is the. So you have to be very careful when you write these equations because a lot of equations are there. So anywhere if you just miss one thing, you write instead of 12 you write 0 like I did in the previous case. Anywhere a minor slip can bring the whole solution, it will be wrong. Okay, so you have to be very careful because there are a lot of equations involved. So we have got 1, 2, 3 equations. Okay, so now what we have to do, we have to substitute this equation 1 in equation 2 and 3. So here we can write from equation 1, I1 is equal to 8 minus 40 I2. that we can also write, we can modify it in that way. I1 is equal to 8 minus 40 I2, and we can substitute this value in equation 2 and equation 3. Suppose we substitute this I1 is equal to 8 minus 40 I2 and 2, and it will become, the equation will be 30 into 8 minus 40 I2 minus 70 I2 plus 10 I3 is equal to 0. That implies 240 minus 1200 I2 minus 70 I2 plus 10 I3 is equal to 0. Or that implies it will be 1270 I2 minus 10 I3 is equal to 240. So what we have done, we have taken this whole thing to the other side. Okay, 1200 plus 70 minus, that is total that much I2, and this plus 10 I3 going to the other side, it becomes minus 10 I3. So let's call it equation 4. This 1270 I2 minus 10 I3 is equal to 240. Similarly, substituting I1 is equal to 8 minus 40 I2 in this equation 3, we will get 10 into 8 minus 40 I2, 8 minus 40 I2 minus 10 I2 plus 12 I3 is equal to 12. That implies 80 minus 400 I2 minus 10 I2, yes 10 I2 plus 12 I3 is equal to 12. That implies 80 minus 410 I2 plus 12 I3 is equal to 12. So here we have this equation, that is 80 minus 40 I2 plus 12 I3 is equal to 12. So we'll just further simplify it. So it will be 410 I2 minus 12 I3, that is equal to 80 minus 12, 60. This is equation 5. Let's call it equation 5. So here we have two equations, 4 and 5. Okay, we have got two equations, 4 and 5, which are in terms of I2 and I3. Okay, 1270 I2 minus 10 I3 equals to 240, and 410 I2 minus 12 I3 is equal to 68. So now we will use variable cancellation method to eliminate one of the variables. So we will be eliminating the I3, that variable component. So for that we will be multiplying the first equation, the top one, with 12 and the bottom one with 10 to eliminate the I3 part. So the result, if we further write the equations after multiplication of 12 and 10, it will be, let us just calculate. So it is coming around 15240 I2 minus 120 I3 is equal to it is coming around 2880. Okay, yes. Then this one is 4100 I2 minus 120 I3 equals to 680. This. So now we'll subtract both the equations. This one become minus, plus, and minus. This gets cancelled, the I3 part, and this becomes let us just calculate. So it is coming around 1140 I2, and this is coming 2200, 2200, yes, 2200 it's coming, yes, 2200. So now we'll calculate the value of I2. That will be 2200 divided by 1140, and that is coming around 0.1974 ampere. Okay, this much, that is the value of I2. So we have got one of the currents. Now we have to use one of the equations. Here we have I1 is equal to 8 minus 40 I2. We can use this to find I1. So we have to substitute the value of I2 there. I1 is equal to 8 minus 40 I2. We'll substitute the value of I2 here. 8 minus 40 into 0.1974 ampere. So the result will be around 0.10053 ampere. That is the value of I1. So we have got one of the currents, okay, I1. Now we have to use another equation to find the value of I3. So we can use this equation, okay, 410 I2 minus 12 I3 equals 68. So I3 will be, by rearranging the equation, it will be 410 I2 minus 68 by 12. So again we'll substitute the value of I2, 0.1974, that is 410 into 0.1974 minus 68 by 12. Let us calculate it. So it is coming around rounding it off, 1.08 ampere, okay. So it is coming 1.079, so 1.08 ampere, okay. I3 is equal to 1.08 ampere. So here we have got the two currents that we wanted to calculate. The current supplied by 8 volt, that is I1, 8 volt which is supplied the current I1, and I3 which is supplied by 12 volt, okay. I3 is supplied by 12 volt. So here another important thing that you have to understand is that it has been asked to find the current supplied by each battery. So here you have to assign the current directions away from the positive terminal of the voltage source and into the negative terminal of the voltage source, because that is the basic rule of current supply, basic rule of network theory. When current is supplied by an element, it flows away from its positive terminal into its negative terminal. So I1 will flow away from the positive terminal of 8 volt into negative terminal of 8 volt. I3 will flow away from 12 volt into 12 volt. And similarly for resistors, because they are absorbing power, it flows into positive, away from negative, okay, for resistors where power is absorbed. So that is very important, okay. So for that reason you have to always assign. Now by mistake, if you assign it in the opposite direction, that is towards, then only thing that here in place of I1 and I3 the value will be negative, minus 0.1005 ampere and minus 1.08 ampere, that will come. So here it means the magnitude is alright, only the direction which we have assigned is wrong. So you just need to rectify it there. Okay, so by mistake if you assign the current direction the opposite, you will get negative value. Magnitude will be right, direction will be wrong. So simply correct it there, convert, change minus to plus, and everything will be alright.